Hi friends, welcome back to our channel. Today we are going to discussing about Kelvin bridge for measurement of low resistance. Okay, and coming for this bridge, here the bridge which contains totally four arms, that is given as R1 and R2, R3 and also RX, and also in between the four arms we are placing galvanometer. This galvanometer which is also called as null detector, and also we are giving DC supply with the help of battery between the R3 RX potential arms, and also here A, B, C are the total three resistance terminals. Here the total three resistance terminal which is also called as lead resistance, that is given as Ry here. Okay. So by changing this Ry lead resistance from C to B as well as B to A, so then only add the external resistance to the both Rx as well as R3 resistance also. So that is the main point here. According to changing the galvanometer, then only resistance can be added to the both side of Rx as well as R3 side also. And also here main thing is, here we have to ultimately calculate it to the value of unknown resistance. Okay, that is given as Rx. Here both R1 as well as R2 and also R3 are the known resistance value. We have to calculate ultimately Rx value here. Okay, so that is given as unknown resistance. So initially coming for the step 1 here, whenever the galvanometer which is placing from point B to C, then only the lead resistance Ry can be adding into R3 side only. Okay, and also whenever the galvanometer B terminal which is changing into R3 side, then only the lead resistance can be added to the Rx side only. So those are the main two considerations which are very important. Now coming for the condition 1 here. So whenever the galvanometer changing from point B to C, then only the resistance which is given as R3 plus RAB. Okay, here RAB which is called as lead resistance. And also whenever the galvanometer which is changing from B to A, at the time the resistance can be adding into Rx side, so then only which is given as Rx plus RBC. Here we know that both R3 value as well as Rx value already we are getting here. So if you want to substitute this R3 value in this as well as this Rx value in this Rx, then only we are getting into the final expression from the Kelvin bridge. Okay, here ultimately what we are to calculating to find the unknown resistance value, that is given as Rx. Okay, so here coming for the condition to Rx plus RBC according to changing of galvanometer lead resistance. Okay, so both R3 as well as Rx, if we want to substitute in the equation 2, then only we are getting like this. Okay, so R1 into, so R3 here R3 plus RAB as well as equal to R2 into Rx, nothing but Rx plus RBC. Okay. So this is the third equation. So if you want to shifting into the Rx plus RBC this side, so then it is equal to R1 by R2 into RA plus RAB. Okay, so this is the equation 5. We are assuming that. Okay, and also already we know that RBC by RAB equal to R1 by R2. So this is the ratio of the bridge which is given. Okay, for simplification purpose, if you want to add plus 1 at both sides, then on we are getting like this: RBC by RAB in plus 1 equal to R1 by R2 plus 1. Okay. So if you want to cross multiply this, RBC plus RAB by RAB equal to R1 plus R2 by R2. Okay, so this is the final expression. So this expression can be, we are giving 5. So if you want to calculate both RBC as well as RAB value, so then only we are getting into the Rx value. So this is the final ultimate equation. And also from the bridge circuit, the lead resistance both RBC plus RAB equal to Ry already we are considering at that time. So that equation we can represent as equation 6. So if you want to substitute this equation 6 in equation 5, then on we are getting like this expression. So from this we can easily calculate it to the one factor, that is given as RAB. So RAB equal to Ry into R2 by R1 plus R2. So this is the ultimate calculation at the bridge one side. Next we have to find RBC. Both RAB, RBC value substitute in fourth equation, then only we are getting ultimate unknown resistance value Rx. Okay, so if you want to substitute this RAB in this place, then only we are getting to the RBC value. Okay. So therefore Ry minus R2 Ry by R1 plus R2. Okay. Now RBC equal to Ry minus RAB. So we can place in RAB value here. So therefore RBC equal to Ry into, here both side is Ry is common. So Ry into 1 minus R2 by R1 plus R2. By simplification by this equation, we are getting R1 Ry by R1 plus R2. Okay. So this is the final RBC value here. Now substitute both RAB, RBC value in equation 4, then only we are getting Rx value ultimately. Okay. So now we are getting, so this is the RBC value and this is the RAB value. So by multiplying entire this expression with the help of both R1 and R2, then only we are getting like this. Okay. So from this expression, if you are observed that, you can clearly understood one thing. Here both side R1 Ry by R1 plus R2 and R1 Ry by R1 plus R2, those are the equal terms. So only here different term is R1 R3 by R2. So this is the ultimate expression equation of Rx value. So therefore Rx equal to R1 R3 by R2. Okay. So this is the measuring of unknown resistance value with the help of Kelvin bridge. Okay. So this is the today our class. If you have any doubt, please put on the comment section. I will give you a reply. Thank you.